Okay, so here's a basic outline of what we're going to be going through, so you can look at that. So I'm probably not going to go directly into like all like a bunch of latex stuff necessarily, but I'll at least go into some of the basics and what to kind of keep in mind. So make sure that if you have questions on specific things, let me know. Also, to clarify for the test review, I don't expect you guys to do the graphs on LaTeX. Yeah, that's a really... Don't do it. Just don't do it. Alright, so once I send the invite link, I'll start doing the actual like lesson stuff. Alright, I just sent the link into the Twitch thing, and I'm gonna send it into pre-calculus, and then we'll get started. Alright, just sent that. Cool. Now let's get started with the real stuff. Okay, so what I was planning on doing with this was to just give you some common errors that I see and just want you to not do. And yeah, so again, if you have any specific questions, let me know. So when you have an environment, you need to begin it and end it when you start. So that's like when you do something like \begin, let's say document. If you use the program that I use, which is what's it called, Text Studio, then it does this automatically for you when you press enter. I don't think Overleaf does this with every function, but some functions and environments it does. But just make sure that you also do the end part as well. Like, type that in when you start, because it's very easy to forget them. So this also goes into some like writing math stuff in general. Parentheses. When you start parentheses, you want to also end them. So sometimes it's easy to, or it's easier sometimes to just do it at the same time. Another error that I've seen people do is they try to use Overleaf on their phone. Please don't try to do that. Even if you're at my level of LaTeX fluency, it's really difficult to use. Yeah, there's also details such as like spelling or these matter, so keep those in mind as you're doing them. Usually when you're using Overleaf, you'll have a drop-down list of things that it thinks you're probably gonna do. So just do that. And format the math correctly. What I mean is, if you want this thing, for instance, what you have to type is $, \sign. Actually, let's say you want that. And then this caret symbol, 2, open parenthesis, then you have to type \theta. So on the last test, I did notice that a lot of people thought that theta was a 0, which is probably why a lot of people here actually wrote that or that. So make sure that for yourself that you write your thetas correctly so that you know what you're doing. Alright. And then, yeah, that's all I really have prepared for the whole LaTeX thing. So if you have specific questions, again, let me know. You can ask through here or you can ask through Discord, whichever one works better for you. Also, if there's any interesting technical difficulties or anything, just let me know. Okay, so I'm gonna review fraction stuff, because, okay, we need it. I'd like to believe that we don't, but yeah, so let's just go through it. Let's try to do it. Make it make sense to yourself. That's all I'm requesting. Okay, so it should be easy by now, maybe annoying, but it should at least be easy to work on. If it's not easy, basically you're just not practicing it, and not, or at least not practicing it enough. So, adding and subtracting, you need a common denominator. Do that. Multiplication, you just multiply across. So you've seen and heard this word cross multiply. What I want you to do with that is get rid of it. That's, I mean, unless you know what it actually is, don't think about it. What it actually means is if you have like this and then you multiply across like that, that's what cross multiplying is. And the only reason you can do that is because you're going to multiply b and d on both sides to cancel out the b's and the d's, so that you have d times a and c times b. And notice this is an equal sign. That matters, because if it's a over b plus c over d, you can't do that. I mean, you kind of can-ish, in the sense that you're going to multiply by d over d and b over b, so you get d times a plus c times b all over b times d. However, if you instead have something like, if you have times, this is the place where things get weird. If you cross multiply, my question is, what do you get? Where is the AD and where is the BC? So that really doesn't actually do anything for you. So when you hear the word cross multiply, unless you know that it's this, do not ever think about it. So I'm just gonna get rid of the badness here, just so that it doesn't intrude our minds. But yeah, so let's look over at this. Let's practice with this. I'm gonna give you some time to work on this, and then I'm going to come and work on it afterwards. So there's 3 that are over here, and there's gonna be 1 I'm gonna go down to also. So I'm gonna just make it so that you can see all 4 of them. And then, okay, alright, this should be quick. I'm going to give us about 5 minutes to do this. Maybe I'll do 6 minutes because of the last one. And what I expect is, as you're doing this, as you're watching this, you are doing this. You're trying it. It does you 0 good to just stare at the screen doing absolutely nothing. So I'll give us 6 minutes. And then I'll project a timer there, so let me just turn that on real quick. And then I'll give you time to just work on that. Of course, if you already started, that's great. So timer right up here. Let me just turn that on. Cool. So everyone can see that. Alright, I'll give it 6 minutes, and you can work on that. Wait, where did my timer app go? Oh, there it is. So once that goes off, I'll be back. Alright, now time is over, so I'm gonna start writing the solution. If you're not done yet, you can just keep working on it. Look at what I'm doing as I do it. Also, I know that sometimes the thing lags. I think it's doing it a little bit more today than usual. I noticed when I set my bit rate, that's like the rate at which the thing uploads. It was a lot lower today than usual. Long story short, that has to deal with my internet speed. I think for whatever reason today it's a bit slower than normal. But anyway, let's see how we can go as well as possible. I just noticed as at the video it goes down by the seconds go down by 2s. So skipping every other second, but oh well, I guess. Let's look at this. So we have 1/4 plus 1/3. They are different denominators, so we can do this to get them to be the same one. This shouldn't be anything new. This is exactly what you've been doing for many, many years. And then when you add that together, you get 7/12. Add the numerators together. Alright, let's do that to number 2 as well. So notice what I'm doing here is I'm already putting those over the same denominator. Because that's what it's gonna do anyway, right? Because this over here, that would just be 3/4/12. So same thing, I just skipped that to go to here. And I'm not gonna dwell on this because this shouldn't be something new to you guys. You know this. Alright, so now we have the same exact thing with this. The only difference is instead of multiplying by numbers, we'll just multiply by variables, which is kind of the same idea, because a number is a symbol, a variable is a symbol. The number is just a symbol that has a specific value to it. Okay, so here we can multiply by y/y, here we can multiply by x plus 1 over x plus 1. So we have x plus 1 times x minus 1 times y, which is just y. Put that all over. I like to just do y times x plus 1 and leave it like that until we know if things can divide out or not, because when it's in factored form like this, it's easier to tell that stuff. Alright, so we can multiply in that x squared plus x minus y, all divided by, we have y times y plus x plus 1. So we see that nothing here can actually divide out, so this actually is the simplest that we can make this. So this is literally it. Alright, the last one. Here we have this. I just noticed we didn't do any division practice. It's okay, we'll do that later with what's it called? Identities. Alright. So here, again, common denominator. What's the denominator? Here is 1 minus sine. What about here? Well, that one is interesting. It actually is cosine, because remember tangent is sine over cosine. So let's just rewrite this thing. Alright, so what do we multiply to each of them to get what we need? Just the other thing. So 1 minus sine over 1 minus sine over here. And then we got cosine of x over cosine of x here. So that would give us cosine squared. And that would be... I'm going to leave it as this first, just so we can not have to process all of it all at once. Okay. Going through this. Cosine squared minus. Multiply that. So that's going to be a negative sign that's going into both of those. So this will be a plus sine squared of x. Okay, so we can collect like terms. Notice we have a cosine squared, and we can add a sine squared to it. So that gives us, as we should all know by now, is 1. So we get 1 minus sine of x, all divided by that same denominator. We have done nothing to it, but remember to always carry over any work that you've done. That can divide out. And when that happens, contrary to popular belief, the answer is not cosine. It is 1 over cosine. So remember, that was division. They don't just, quote, go away. That's why, notice, again, I always say divide out rather than cancel out or goes away. Okay, sure, sometimes I say that it gets, like, killed off or something, but you get the point. And this can actually simplify to secant, so cool. If you have any specific questions on this, again, ask either in Discord or here. If you're watching this not during the live time, then obviously, yeah. Okay. Alright, function composition. We have been doing this for quite a while. So make sure that this makes sense. I need to take the timer out so you can read the rest. Oh shoot, was the timer in the shot when I was doing that? Okay, so if the timer was in the shot, I think it would only affect this one. Just take a quick picture of this if you need to. And then, yeah, sorry. I keep forgetting to... This is what happens when you have multiple windows. Alright, I'm gonna move now. And let's talk about function composition. Again, this is something we've been reviewing for quite a while now. So, what is it? It's just putting a function into another. So, if we had this as two functions, notice that I color-coded this. One is, some of the stuff is blue, right? Because what we're doing is we're going to find f of g of x. In other words, we're going to put g inside of f. What does that mean? That means this will replace all of the x's in that function. So if you watched the stream last time, this looks familiar because I copied this, because people clearly didn't learn it from last time, so learn it now. It was in the stream. That means it's going to be on the test, so, you know, do it. Okay, so that goes in there. So we have f of g of x equals the square root of 3 times that entire thing. So at this point, you can kind of just like, don't overcomplicate it. All you really do is you're just putting that inside of the x. So exactly where the x is, that goes. And then what can you do with this? Well, the 3 is going to multiply to both of those. So notice, both of those, not just one of them. So we get the square root of, that's going to be 3 times 1/3 is 1. So x squared plus 3. Then we get minus 3. So the plus and minus 3 are going to subtract. And then we just get the square root of x squared, which gives us just x. So that's a nice, interesting result. What if we went the other way around? G of f of x. I want you to kind of do that one on your own real quick. I'll give us, let's say 3 minutes to do that. That's actually probably way too much. I'm going to give us 2.5 minutes to do that. So you just saw what I just did there. Do that here. So, where's the timer? There it is. 2.5 minutes, go. So as you probably noticed, I already started doing some of the work. That was just so that we can save some time, because I did spend a bit of time like just letting y'all do that the other time and all that. Yeah, so alright. Yeah, I'm just gonna continue this. I'm pretty sure you can do this algebra yourself. Just be careful. So I'm not really going to explain what's going on here, because this should be something that makes sense to you. Notice that they both equal x. If you have, again, if you have questions, ask. I'm not going to go over every little detail, especially not the things that you should be expected to know by now. Alright, so looks like I haven't gotten any questions, so I'm going to just move on. Alright, so inverses, again, this is something we have been reviewing for quite a while. So yet again, please learn it. Don't just learn it for one test and then forget it. Actually, y'all didn't learn it for the first test. You should learn it now. Okay, so things are inverses if you compose them together both ways and they equal x. So what's an example of inverses? this. So you've done that calculation there. So what I want you to do is do that here. I'm going to give us, again, some time to do it. And then see if they're inverses or not. So I'm going to give us 4 minutes on this. Partway through, I'll come in and just start doing the work so that we can just review it real quick once once the timer is up. I'm just gonna work on this, and then you can kind of check your work and see how that's going, as you finish, as I finish. There will be pretty minimal explanation in this part because these are things that, again, should be known. If not, you gotta ask. So if you haven't been paying attention, or normally don't retain things, or just choose not to, this is called therefore. Again. So as you did this, if you did it correctly, you should get x for both of them, and they are both equal to x, and therefore they are inverses of each other. Alright, and this one over here. You might see where this one is going. And since this already doesn't equal x, we already know f and g are not inverses. Alright, so let's move on to the next one. Find the inverse function. So I'm gonna just tell us what I'll just do this. I'll do 1, and then I'll have you do 2 on your own, and then we'll move on after that. So again, what you need to do is just, this is your y, so to speak, right? So here's your x. So essentially just switch those two and it would solve for y, because that is going to make you systematically get rid of all of the operations and undo them, because again, inverses means that you undo all operations done on a function, or done in using the function. So the first thing we can do to undo that cube root is cube the whole thing. X cubed equals 3, y squared minus 4. You might be tempted to divide by 3 first. That would be called wrong. You want to add this thing over first, the 4 over first. So then we end up with x cubed plus 4 equals 3y squared. Now you can divide the 3. So we get x cubed plus 4 all divided by 3 equals y squared. And we can square root that. And then what we would end up with is the square root of x cubed plus 4 all divided by 3. And how to properly, well, that was a terrible f. Right, this is f inverse, so that's what that -1 means, equals the square root of x cubed plus 4 divided by 3. Some of you might be wondering, wait, I thought it was supposed to be plus or minus because we square rooted. Technically, yes, actually. Except one thing. If we were to do plus or minus here, the function would actually look like this. A sideways parabola. So the problem with that is because that doesn't pass the vertical line test. So instead, what we would do is actually instead just choose the positive one. So instead of plus and minus, it's just plus. So remember when we had like this kind of thing going on, we just chose from here to here. So it's that same idea. We only chose a certain amount. Alright, so I'm gonna give you... it shouldn't take that long to do this. Just remember, one of the things you're gonna end up undoing is sine. Remember how you undo sine is with the sine inverse function. So this will be used somewhere. So you should understand how that works. There's only one small thing where that has to happen. Do not trigger yourself with this. So I'll give us 3 minutes on this one because it should be fast. Although I guess fast, in my opinion, should be like a minute. But yeah, let's just do 3 minutes. Hopefully that doesn't take up too much time. And yeah. Alright, so as you see here, I'm basically there. Alright, so this is what you will end up with. So I'll kind of walk through that. I know there was a lot, more than we normally try to process in one problem at the same time. So first I just move the 1 over. So again, we're systematically getting rid of things to get that y alone, right? That's what we've said, that's what we've been doing, so please learn it and do it. But yeah, so get that 1 over. Then you can multiply by 2 to get rid of that 1/2, because that's multiplying. Then we can square root to get rid of the squared. And then you want to get rid of the sign using sine inverse. So you sine inverse the entire thing, both sides. Then we get sine inverse of the left-hand side equals, this thing gets released basically, 4y plus 3. And then you can subtract 3. Remember, normally we put the number in front of the trig function. That's just normal convention. And then divide by 4, then we get this. So notice that we're just doing things like kind of slowly, simply, just go, essentially. So if you look at it that way, it'll go smoothly. If you overcomplicate it, you will not get this. So please just get this. Alright, so this one is something that, for whatever, I don't understand why people are having so much trouble with this. Because you guys did this a lot last year, so this shouldn't be anything new. This is definitely review, so make sure that this makes sense to you, especially because it is review. I'm mostly concerned because it's review and people are like, what? Alright, so sine. This is that thing. So trigonometric functions, let's just start with there. Like sine, take in an angle, output a value. Versus something like sine inverse. You take in, what's it called? You take in a value and you output an angle. So basically, what sine will tell you is if you're at an angle, what's gonna be the ratio in the unit circle, which comes from a triangle. And in sine inverse is, here's the ratio. What angle makes that happen? So, let's just do that real quick. So, actually, I want to give you a chance to do this real fast. So, just do that, and then we'll go over this. Because I don't want to... Well, I guess I'll just use a really quick review, basically. If you think of the unit circle, sine is your y value, cosine is your x value, tangent is your y over x, right? And then cosecant is 1 over sine, so that'd be 1 over y. Secant is 1 over cosine, so that's 1 over x. Cotangent is 1 over tangent, so that's just x over y instead of y over x. So I'm going to erase this because it's stuff you should already know. I don't want to clutter the area. And for sine, I'm just going to do this. So remember, you're going to do, what is it? This is going to be between negative pi over 2 and pi over 2. So that means for this, whatever angle that's within this range that will give you that ratio with sine is going to be the answer to that. That's what it'll evaluate to. Cosine is from 0 to pi. Tangent is from negative pi over 2 to pi over 2. Probably gonna have to quiz you guys on this, or like do some sort of like quick thing on this to make you learn it, because this is pretty important. If you don't know this, this will probably debilitate you in certain places after this class. So be open to learning it and just choose, I'm gonna learn it. So I'm gonna give you a few minutes. Let's work on this. Try to get it as best as you can. Also, on the final review, I think there's like 20, 30 something of these specifically. So if you don't get it by then, yikes, is all I gotta say. Yeah, let's do 3 minutes again. If it's bothering you what the music is because it sounds familiar, yes, it is Pokemon. just realized the music was up there. Oops. Hopefully that all made sense. And you could hear. Anyway, verifying identities. I'm gonna give us... this one shouldn't take more than 3 minutes, so I'm just gonna give us that, and then, while you're doing it, I'm gonna do it as well. Obviously, it doesn't help you to just stare at what I'm doing and not try it yourself. It's just so that you can check it when you're done, so I'll give us 3.5 minutes. Work on it. I'll work on it as you work on it, or I'm gonna start working on it, like, at 2 minutes or so. Oh yeah, also in the music it might be bothering some people to like that one part's a little bit laggy-ish. Yeah, that's what happens when you try to write something for the clarinet really low, like literally as low as no. I recorded that. Yeah, I hadn't played in a while, so I gotta practice. Alright, so, yeah, it would have been done a bit earlier, but for whatever reason, I think the timer is lagging my Photoshop or something. Maybe there's just too much stuff open. But anyway, the trick here is just break the tangents into sines and cosines, and then common denominator it, and then divide. So dividing, remember, top times the reciprocal of the bottom. So flip the bottom, multiply it to the exact top. Don't do anything to the top. Just leave it as is. Alright, and then there's that. Maybe OBS is lagging this also. So yep, that's all it is. Alright. Next one is over here. I'm just gonna give us 3 minutes. Cause we've kind of already did this-ish. So just 3 minutes. Work on that real quick. There's a chance I might not be able to go over and explain all the graphing at the end. Just because I have 2 of these, and then, yeah, we might only be able to go through one graph with explanation. But I'll just do all of the rest of it, kind of just like, not exactly stream style, but yeah. I'll make it work and then upload a video if it doesn't get done here. So, there's the timer. Huh, this track is really long. I don't know how long I made it. While you're doing it, I'm gonna do it as well. Obviously, it doesn't help if you figure out what I'm doing and not try yourself. It's just so that you can check it when you're done. Okay, yeah, I think I've confirmed that for some reason the timer lags my Photoshop a lot. But yeah, so I just common denominated both of them, and then just distributed the cosine into the 1 plus or 1 minus sign. Notice that I made a mistake over here. That should be theta. So I somewhat purposely did that just to like show, hey, look, there's a thing to not do. Just to highlight that. Because you will be marked down if you do that. If I give you a variable, just use that variable. Be glad I'm not giving you some like Chinese character or something as a variable. Maybe second semester. If I do that, I'll definitely write out like how to write it on the board. Okay, maybe is there something else also lagging it? Because this is going faster, but still fairly laggy. Don't know what's going on exactly. But anyway. Let's see. Oops, wrong thing. That will subtract with that. And the other two will combine. Because we have the same thing added twice, we have 2. Sine theta, cosine theta. All divided by, we know by now, or you should know by now, that that equals cosine squared theta down there. So cosine from there, and one of those can divide out. Then we get 2 times sine theta over cosine theta. In other words, 2 times tangent of theta. Alright. Then we have this one. So I'm gonna get us started on this one. It's a bit of a trick. So, or like there's a bit of a trick that you need to use here. It's an algebra trick. So notice that this is something squared plus 4 times something plus 3. So let's just say let's just use the letter u equals sine of x. You might also be thinking, wait, what about the bottom? Remember that can turn into 1 minus sine squared. So what's going to happen is we get that divided by that. So this thing can factor, and it'll factor into that should be u plus 1 times u plus 3. I'm pretty sure you can do this by now. Again, one of those things where if not, then yikes. And then, so the bottom, that's going to turn into 1 plus u times 1 minus u. And u plus 1 and 1 plus u are the same thing, right? And they are factors, so they can divide out. And what's left is u plus 3 over 1 minus u. In other words, we end up with u is sine, so we can replace that. And I'm just going to write the 3 in front, actually. Because it's addition, so we can change the order, right? So this is just 3 plus sine of x. All divided by 1 minus sine of x. Oh, so the playlist is repeating. I haven't recorded that much music yet. Alright, so we get that, and that is what we're looking for. So this one was a bit tricky, if you didn't quite see that immediately. So that was in one of the hints that we had in the homework. In one of them, I don't remember which one. But in case you were curious about that and you didn't quite get how I got that, that's how I get it. And also, if you didn't quite get how I got it, just saying, you should have asked. I just want to re-emphasize, if you don't get something, please ask. Please don't wait till the test time or quiz time or I call you up to the board time. Just please ask as soon as you possibly can. Thank you for those who do that. Yeah, English is a struggle. Alright, so now we're on to graphing. I just want to show one really, really quick difference between two things before I go into doing it. So you have seen both of these before. Okay, why is this all lagging? This is gonna be interesting then. So I'm just gonna... So, that's equation 1. You've seen... This is what I think I gave you first, and then I noticed a lot of problems. For whatever reason, I used this. I think I did that last year because the book did that. But note those differences. Yeah, so the thing about that is one of them has parentheses, one of them doesn't, inside of the function. The difference there is basically you can kind of think of it as in the yellow one, there's just numbers in there, we're just working with the numbers. In the blue one, they were special enough where we could have factored things out. So in equation 1, the yellow one, you actually do have to use h over b. There were a few people that used h over b in the last test when it was actually in the form of the blue one. So I chose to do the blue one just because that's what your homework mostly had, and therefore you were probably practicing that more. So this time you'll see a combination of both. Just make sure that you figure that out in your head. Alright, so now we're gonna practice graphing. I think I have 3 of them. Yeah, chances are we're not gonna get through all of them, so I'm going to graph... You've seen a lot of trig transformations, so... I'm going to just graph this one, and then I think I'm just gonna end the stream because it's just... I don't know, it's lagging a lot. It might partially be because I'm streaming and recording at the same time. Just so that I can catch any of the things that I need to, just in case. So I think I'm gonna stop the stream after I go through this one. Just so that... Actually, I think I'm gonna stop the stream right now. Just so that I can... yeah, there's just... The technology is just going really weird today. So you're gonna stop the stream right now so that, you can look at this later, and you'll have it more smoothly. Because I think if I only record, then it should be fine. Or I don't know, we'll see. Alright, so I'll sign off on the stream right now. See you all later. And... Alright, so at this time, the stream should have stopped, and you are probably watching this as a, recorded video. So for those who are watching as a recorded video right now, you can just continue on. I'm gonna hide the identities list, and for the timer I'll just move it a bit more down. So I'm gonna give us some time to work on this. So since we haven't done something like this in a while, I'm just gonna say, okay, here are the reference points. And then after that, I'll give us one more quick thing and then get us started. And then you should get started. Okay, so we have 0, 0, 1, 1, negative 1, negative 1, 2, 8, negative 2, negative 8. So how did I get those? Partly because I know what this function is. It's the x cubed function. How do we know? Because of that cubed. So parent graph is x cubed. And then we can look at the transformations. I don't understand exactly what is the problem with this, but a lot of people are just skipping this. Learn it. I'm just telling you, learn it. Don't just be like, this looks hard, I'm not gonna do it. So just learn it. Not too difficult if you just try it. But you gotta practice it. If you don't practice it, it's not gonna work. So let's see, we have negative 1/2 as our a value. So I guess we can list those. A, B, H, K. In this case, because we have that in there, we don't have to account for h over b, so the h here is just going to be exactly what it is. So a is negative 1/2, b is 2, h is 3, and k is 1. So that means we have a vertical scaling by negative 1/2. So that also means that that thing's going to flip over the x-axis, actually. So the b, this is going to be a horizontal scaling by 2. So you divide all of the x's by 2. And then for h, this is a horizontal shift 3 units right. And for k, that's a vertical shift 1 up. Alright, so I'm going to give you some time to work on this and try to get it as good as possible. Actually, because this is the recorded video version now, what I want you to do is pause the video right now and then unpause it, and then you can see the work that I do. If you need some of the work, obviously you can just click, or just not click pause, or just go ahead to part of it. But it would benefit you a lot to try it paused and then see how it goes afterwards. So I'm gonna assume that you have paused and now you're resuming because you are done and checking. So here are the scaled points. So in other words, we're just taking all of the reference points and then doing the scaling to them. So for the negative 1/2, we're going to multiply all the y values by negative 1/2. So we get 0, negative 1/2, 1/2, negative 4, and 4. And then, let's see, horizontal scaling by 2, that means we divide every x value by 2. 0 stays as 0, then we get a half, negative a half, 1, negative 1. Alright, that was quick and easy. Shifted points, and to be honest, this should be very easy and quick by now, just because we've done it so much that if you don't get it, literally you're just not practicing. So make sure you're practicing. And then shifted points, we're just going to take all of the scaled points and we're going to shift them. So horizontal shift right. That means we're gonna add a 3 to all the x values. So starting with the scaled points here, add 3, add 3. That's, it is not 3.5. Well, technically it's 3.5, but I want you to get used to doing it as fractions. So that'd be 7 over 2. You can use 3.5 for the graphing part. And that'll be, let's see, that'll be 5 over 2. Add 3 there, we get 4. And add 3 there, we get negative... Wait, yeah. We add 3, so... we get 2. Okay, add 1 to all the y values. We get 1, 1/2, 3 over 2, negative 3, and 5. So we don't have a whole lot of negative either way, so I'm just gonna do this without too much regard for the negatives, and then, so that'll be x, y. And then, let's see, highest y value we have is 5. And, oh, we don't have any negative x values, so it's gonna be very over here heavy for now. So let's see, 1, 2, 3, 4, 5, 6, 7. Let's just do that. Highest x value you have is 4. 1, 2, 3, 4, 5. And just do that. Okay, so let's say we have 3, 1, 3.5, 1/2. Then we have 2.5, 1.5, 4, comma negative 3. And then 2, comma 5. Or sense. Ooh. So that's going to look interesting. So I'm gonna do it kind of like this. Let's see how I can, maybe let's just connect it point by point. Something like that. Okay, so this is more or less what that should look like. Alright, so gonna go on to the next one then. Again, you can pause here, email me, whatever if you have questions. I'll probably be on Discord like all week also. Okay, here's this next one. Again, like I've been saying, I suggest that you pause the video, try it on your own, and then check it. So I'm gonna start the problem, assuming that you have done that in 3, 2, 1. Alright, so there are the reference points. For the final exam, I'll have a set of reference points written on the board. You will not use all of them. You will have to choose whatever the correct ones are. I'm not sure how I'm gonna do that yet. I might have the entire thing written like let's say we have 3 graphs. I might have like 5 sets up. You have to choose from that. Or I might just have 3 and you have to choose which one is which. I don't know. I haven't decided yet. But yeah, so here, notice that there's no parentheses in there, so you have to account for h over b. So I'm going to write that over there as well. A is, oh no, there is no number. Whatever shall we do? That's -1. B is 1/2. H is pi over 2. So h over b is pi over 2 over 1/2, which would reduce to pi if you've been paying attention and or trying with division. So, just for time's sake, because I've been at this for like an hour and a half already, I'm just gonna skip the writing transformations and I'm just gonna do the scaled points and all that stuff. But you should definitely write down the transformations. It will help you process it. I've already done enough solutions on those, so by now you should know what that is and you should understand it. If not, watch the video. If not, you should watch the videos. You should practice more. I think you're getting the point. You need to practice more. And if you're watching this going like, yeah, that's right, I should do that, then, you know, do that. And again, just for time purposes, I'm doing that. Okay. So for the scaling, a is -1. We're going to multiply all the y's by -1. B is 1/2. We're going to divide all of the x values by b by 1/2. In other words, multiply by 2. And then make sure that you do that to these as well. And then shifted points. Here we have h over b equals pi. So we're gonna, oh, actually, sorry, that's -pi. Because that's a plus there. So that means it's minus -pi over 2. So we're going to subtract pi from all of the x values. So from these x values. And then we're going to subtract 2 from all of those as well. And then, oh yeah. -2 pi, 0. Alright, cool. So let's get this thing going. We have a lot of negatives, so we probably don't need too much on the positive side. I feel like I might have done this problem already before. Yeah, I feel like I might have done this on like a homework problem or something, and I just accidentally made up the same problem again. I mean, anyway, let's do this. Oh, how did that happen? I'm gonna do my asymptotes in blue, just so that it's different. So we got one there, got one there. You could also extrapolate it onto the other side if you made space for that. And then let's see, what do we have? We have negative pi and negative 2. Negative pi over 2, negative 3. Ooh. 1, 2, 3, 4. I think it'd be like there-ish. Whoops, forgot to account for that. And that'd be at negative 1, so I think it's there. And then it would expand upward as well. So let's just... It looks something like that. Just gonna stroke that path. Then make it go in this way also. Stroke path. Cool. And I guess if you're watching this, you can get a free, like, Photoshop tutorial-ish. How to use the pen tool. Yeah, so that's that. Alright, last one. This one. Reference points, so remember that's the one that goes like this. And just goes to the x-axis. And y-axis is like in the middle right there. So if you know what this looks like, that kind of helps with remembering the reference points. So that'd be negative 1 comma pi. 0 comma pi over 2. And then 1 comma... Wait. Yeah, 1 comma 0. I almost wrote something else. No idea what I was thinking. Alright, so let's look at how this is going to look. The nice thing about the inverse trig ones is usually there's only... Well, okay, sine and cosine. There's only 3 points to deal with. And notice over here, no parentheses, so no parentheses in there, so we deal with the h over b again. Alright, a is 2, b is 2, h is negative 1, so we got negative 1 over 2, and then we have negative pi over 2. Alright, let's do this. Okay, I've been writing for so long. Hold on, I'm just gonna rearrange things a little bit, switching to my other hand. I think most of you by now know that I write with both hands, right? I feel like by now that's common knowledge. Alright. So, scale points, we're going to multiply all of the y values by 2, so we get 2 pi here. Then we get pi, and then 0. Alright, now we're going to divide by 2 for all the x values. So we get negative a half, 0, 1 half. Alright, h over b, we're going to add that to all of the x values. So negative a half minus a half. It's gonna be negative 1. Alright, that's nice. And ooh, we got a 0 there. That's even nicer. Okay, pi over 2. Subtract that from all of these. So we get 3 pi over 2. Pi over 2. and then negative pi over 2. Cool, so I'm just gonna center this. Cosine inverse usually just looks nice when centered in general, unless there's like huge changes, which I don't think there would be in this case. Alright, so looking at our x values, we have lots of negatives, so 1, 2, 3, 4. I'll just make that negative a half. Negative 1. Just gonna do the same thing going to the right. And then up and down, I'm just gonna make that that's gonna be pi. 2 pi. And then again, same thing going down. Alright, so let's plot those points. Negative 1 comma 3 pi over 2, so that's up there. Negative half comma pi over 2, that's over here. And 0 comma negative pi over 2, that's over here. So I guess if you are interested, there's this thing. I don't know if you can really see it, but there's a thing called the pen tool. If you want to know how to get to it exactly, you can ask me later. But basically, I can click there on that first dot and then go to the second dot and then create a bit of a curve there. So I think you can see that, right? And then notice that there's that little path thing. If you're using a Mac and you want to reset the curve from here so that it doesn't get influenced by the previous one, you can press Option and then press that there. And then I'll click on this next one. Then I'll just do this thing out. Fun fact, actually this little thing that's going around, that is actually in calculus what we would call the tangent line to the function. So we're actually doing calculus here. Photoshop is calculus. Anyway, so I actually am literally using calculus to help me graph this thing with Photoshop. So then you can click, basically right click and then go to stroke path, and then it'll ask you what kind of thing that you want to use to stroke the path with. You can't see that window, I don't think, but you just press OK, press enter, and then that thing just gets filled in right then and there. So kind of cool. So math lesson and Photoshop lesson all in one. I use that to draw certain things on Photoshop. Alright, so that's the end of this. That was a pretty long recording / stream. So it's the end of the semester. Study hard. And yeah, ask me any questions if you have them. See y'all later. Good luck. Ganbatte. 加油。ありがとうございました。